Okay, good morning. Today we are going to talk about mole-to-mole stoichiometry. We're using balanced chemical equations to do that. It is our way to determine how much of something we might need or how much might be produced of a certain compound or element. This is similar to if you're having to figure out if you have enough ingredients to make a batch of cookies. If you don't have enough eggs, then your eggs would prevent you from making more and would dictate how many cookies or how many batches of cookies you can make. So it's similar to what we've done before. We will have to figure out what is given to us in the problem and what we're trying to get to. So if we look at the first problem, it says how many moles of CO2 will be produced from 15 moles of oxygen with excess C3H8. So our given in that problem is what follows the number that, or the amount that we have. So our given is going to be 15 moles O2. What we're trying to get to is we're trying to figure out how many moles CO2 are going to be made if we only have 15 moles of oxygen. So the way we set that up is just like before. We'll set up our T-chart. The beginning of our T-chart will be what we're given, so our 15 moles O2. Now, this next section is what we call that mole ratio. We talked about that in our last lesson. It comes from the balanced equation. So we know that our given has to be O2, which is going to be down here. And what we're going to, CO2, is going to be on the top, and then we need to go up here to the balanced equation. We're going to use the coefficients that are in front of those compounds. So we have a 5 in front of O2, so we're going to put a 5 mole in front of O2, and we have a 3, so we're going to put 3 mole in front of CO2. Now, like before, our moles of O2 are going to cancel. That gives us 15 times 3. 15 times 3 is going to be 45 mole CO2 over 5. The next step then would be to divide. 45 divided by 5 gives us 9 mole CO2. Now, the area that you guys are going to make mistakes is right here with our mole ratio and not putting the right numbers in front. Remember, this second section right here is always going to come from up here at the balanced equation. So make sure that that's what you're doing in that section. Let's look at our next problem. We're going to use the same equation, but we have different substances. So in this problem, it says how many moles of water will be produced when 9 moles of CO2 are produced. Our given, again, is what follows the number. So 9 mole CO2. And what are we trying to find? Question mark, moles of H2O. So again, we set our problem up. We always start our problem with what's given, so our 9 moles of CO2. And then that next section, remember, is the mole ratio that comes from up here at the balanced equation. But we have CO2 has to be on the bottom, so it will cancel, and we're trying to get to H2O. So we go to the balanced equation. The number in front of CO2 is 3 mole. And the number in front of water is 4 mole. Moles of CO2 are going to cancel. 9 times 4 is 36 moles H2O. Don't forget to pay attention to what's on the bottom, which is 3. 36 divided by 3 is 12 mole H2O. Again, here make sure that we multiply across the top, multiply across the bottom. If you don't have anything underneath, you can always put that smiley face. But make sure that you bring that bottom number over so that you'll finish out your math correctly. Going on to a third problem. How many moles of carbon are needed to completely react with 0.5 moles Fe2O3? So our given would be 0.5 mole Fe2O3. And what are we trying to get to? Question mark mole of carbon. So again, set up the T-chart. We always start with what we have given, so 0.5 mole Fe2O3. Then remember, whatever we start with, that substance is going to go on the bottom, so Fe2O3. And what are we trying to get to? Carbon. So now, second section comes from the balanced equation. Fe2O3 has a 2 in front of it, so 2 mole Fe2O3. Carbon has a 3 in front of it, so 3 mole of carbon equals moles of Fe2O3 cancel out. 0.5 times 3 is going to be 1.5 mole of carbon over 2. Continue to do that math, and it leaves us with 0.75 mole carbon. If you're having difficulties with this, you just need to remember to slow down, make sure you have the right thing given, make sure that you're pulling the second section from your balanced equation at the top, and it should all work out for you. So next problem, how many moles of Fe are produced from 0.25 moles of carbon? Are given 0.25 mole carbon, and we're trying to find question mark mole Fe. Set up your T-chart. It begins with what's given, 0.25 mole carbon. Remember, that means that carbon is going to go on the bottom, so it will cancel. And then what we're trying to go to, Fe, will go on top. We're going to go back to that balanced equation that we used before. Pull this back down again. So our carbon has 3 in front of it, so that's 3 mole. And Fe has a 4 in front of it, so that's 4 mole. Equals, moles carbon are going to cancel. 0.25 times 4 is 1.0 mole Fe divided by 3. And what are we going to get? So 1.0 divided by 3 equals 0.33 mole Fe. So this last one I want you guys to try on your own. You're still going to use that same equation, but I want you to pause your video and do this problem by yourself. Treat it like a learning check. We will have another assignment that you will have practice problems, and we'll put your answers into a Google form. So pause, do the problem, and now we're coming back to this problem. Our given, in this case, is 1.25 mole CO2. We're going to question mark mole Fe2O3 using that same balanced equation we used before. Set up our T-chart. We have 1.25 mole CO2. Remember, that means that CO2 is going to go on the bottom. Fe2O3 is on top. We go back up and look at that equation. That means that we will have a 3 in front of the CO2 and a 2 in front of the Fe2O3. So 2 times 1.25, oops, sorry, forgot to cancel, is going to be 2.50 mole Fe2O3 divided by 3. 2.50 divided by 3 equals 0.83 moles Fe2O3. Hopefully this was simple enough to follow. Again, I will give you some more practice problems for Wednesday for you guys to practice on, and we'll see how that goes, and then we'll start looking at going from grams to moles on Thursday. Thank you so much. Make sure you message me, or shoot me a message through Remind, or comment on your assignment, and I will get back to you.